Hello, and welcome to the Veterinary Anatomy in VR project. Purpose of this project is to provide an educational platform that students may use to learn about the anatomy of different animals. Currently, this project includes 3 animals: canine, bovine, and equine. The whole point of this project is because in a normal academic setting, textbooks are 2D, which offer a limited view, while cadavers can be very expensive and can be damaged through use. So we want to create another way to learn about animal anatomy by embracing the ease of access that books provide while keeping the 3D element that cadavers or other animals have. So right now we're starting with the simple, this is what anatomy is. We're giving the information on the basics of everything and where everything is located. And then as this project progresses, we'll further expand upon this by adding quizzes and more information, more functionality, and so on. So we're hoping to make this as useful as possible within the academic setting. Currently, we use Unreal Engine to make the process, but we are going to be moving into a web-based development system, allowing for an even greater ease of access. Everyone can, or you don't have to download an executable, you can just sign on to a website. This project was created through a collaboration with veterinary students as well as computer science students and art students.
For the process of digitizing the skeleton, our team used 2 main methods to bring the skeleton into the 3D space. Our first was to using the Artec handheld scanner to capture the point cloud and convert it into a workable base to start off from. The next step was to clean up the data with 2 main goals. One, to fill in any missing data and enhance details that were not captured by the scanner, and 2, retopologize the mesh to where it's detailed yet not as dense for Unreal Engine to process in VR. A team of artists used 3D sculpting software for this process. After the process of cleanup is completed, our team was also able to extract each individual bone for the veterinary team to inspect. This process also allowed us to bring the topologies down to a manageable count where Unreal Engine can process it within real time and in VR. Our next goal was to bring the color data back into the 3D model, so we used the PBR texturing program to get those details back. Also, within the program, we were able to work with various maps to be able to get the best quality for this experience. Our next goal was to bring everything together using the low poly model and the newly created texture maps and bring it into a real-time rendering engine to inspect. Our goal was to have a low costing model yet having high color detail for user to inspect.
Hello, my name is Daniel Imondo. I'm working on the WebXR Veterinary Medicine project for the Aries group at Virginia Tech. Basically, my goal with this project was to bring this model and information on the skeletal system of a horse to the world in a very accessible way. There's no need for downloads or a specific platform. This project is accessible anywhere as long as you have a browser ready to go. And in making this, I was carefully considering each step of the way. How can I make this project be more and more accessible? And that meant in cutting down on the costs of load times. And if you'd like to see here, we load in. And just like that, from anywhere in the world, you have access to this equine model. This is on a local host server, so expected load times for actual users once this is hosted on the web are believed to be a little bit longer. This was achieved using the 3JS library, And you can see, as far as current functionality, you can zoom in and out, move around, and select any bone. This will be labeled on the right. And there are more planned features to come.